Question 3, and we'll begin with part A. So it's asking us to find the integral of sine squared x dx within the bounds of 0 to pi on 4. Now when you see sine squared or cos squared in an integral, you should always think of the double angle formula. So we know that cos 2x is given by 1 minus sine squared x, or it can also be written as 2 cos squared x minus 1. But since we're dealing with sine squared, we're going to be using this. Okay, so now that we know that cos 2x equals this, we'll try and make sine squared the subject to make our integral integratable. So we'll bring the sine squared over and we'll swap it with the cos. And now we'll just divide by 2. So there you go, sine squared equals half 1 minus cos 2x. So now using that, we can now replace sine squared x in here with what we've just found. Okay, so now we take out the half, because it is a constant, and we can do that with our integration. Alright, so now we know we can integrate both of these things. So integrating this between the bounds, we know that the integral of 1 is x, and that the integral of cos 2x is actually 1 over 2 sine 2x. And we put our bounds in the corners of our square brackets. Okay, so now it's just a matter of substituting our values. So we leave the number out here. And now if we substitute pi on 4 into this, we're going to have pi on 4 minus a half. And then pi on 4 times 2 is pi on 2. Sine pi on 2 is 1. So we'll put 1 here. And now we take away this thing substituted with x equals 0. So simply we put 0 now, and sine of 0 is 0 as well. And now it just comes down to simplifying. So we've got still the half out here. We have our pi on 4. And now we take away a half. Now if you want, you can make this the same denominator. So we'll just times both sides of a half by 2. So we're going to get 2 over 4. And now we just multiply the denominator by the other denominator. And so your final answer should be pi minus 2 over 8.